Gentlemen and small women and children. We're going to do two at the same time. We're going to do ROs number 25 and ROs number 26. RO number 25, the Texas Star Sweet 16. The trouble I'm having with this Texas Star Sweet 16 is that I let the smoke out of it. LOL. What really happened is I was putting a new radio into my truck, and the carrier was obviously too high. When I keyed up the amp, I noticed the problem right away, and I turned the power off to the amplifier in about 2 seconds. It took me a little bit longer to unplug it from the main power source. However, the magic smoke had already escaped. Please check and get back to me. RO number 26. RO number 26. This was originally a Seeker 250. Now it says on it Robin Hood 250. Can't wait to find how this works. Okay. Was originally a Seeker 250. Complete with unregulated power supply. After many years of unregulated voltage, the MRF 455 family gave up the supply, or gave up. I had a friend rebuild the amplifier. He suggested putting a switchable supply, which he did. The supply is emitting harmonics to any receiver in a room with the amplifier plugged in to the wall and turned on. This is the only problem I have with this amp. I hope you can solve it. Okay. What we have done is we've turned on the ICOM 7300. We have turned on the bench it's a coax connector for the 7300. Turned on the bench 2950. I don't see anything on the radio. Okay. Common ground. Say radio. There it is. Oh, that's horrific. Okay. Oh, that's sweet. Okay. It does definitely have a noise issue. Sorry that was so loud and probably painful for all of you guys to listen to. But it does actually have an issue. I noticed right away when I took this out of the box. And it looks like the cabinet has been extended. Me personally, I cannot wait to see what is going on underneath here. I just can't. I'm gonna jump right into this right now. I can't. I love the home craftsmanship. I think that's awesome. This concerns me with the fan, but hey, what do I know? Might have been an afterthought. I cannot wait to see what's going on the inside of this. Oh boy. Oh. This just keeps getting yummier as we start to peel back the layers of the onion. Oh, wow. 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 Styrofoam to help hold the switcher in place and everything. Wow. How well that's working out for them. Look at that. That's beautiful. This one piece of coax here is held on by exactly one strand of wire. Hmm. I want to know what's going on in here. Oh, no, wait a minute. Hold on. Let me back this out a minute. Got to get me a little before picture. Oh my Jesus. This is hot. 1, 2, 3, 4, 5, 6, 7. 7 wire nuts. 1, 2, 3, 4, 5. 9 butt splices, clip over ferrite here, clip over ferrite here. Wow. Oh, wow. Okay. Okie dokie. Okay. I can't stop looking at it. This is amazing. So the sideband circuit, which is the, I don't know what wire it is here. Let's see. This is a white wire, goes through this piece of ferrite, goes to the capacitor. The keying circuit, believe it or not, is hanging out in this mess of stuff here. How this is working with that wire touching the... Anywho, okay, so sideband does work. It's got a delay, but then this is grounded. There's no bias on this. This is a Texas Star board, by the way, that has been cut down, just so you know where the board came from. It has been completely rewrapped. Okay, anyhow, I talked with the customer. He's not too interested in spending a lot of time or money on this. I told him what I really want to do is a before and after where we take literally everything out of here for safety reasons, period. And we just start over. I put a brand new HP little switcher in here for, you know, 30 bucks or whatever. And then we put, move the relay over and at least secure it down so it's not moving. Change the coaxes out, that kind of thing. And then we figure out what the hell's going on with the amp in the back. This gentleman is visually impaired, and I think somebody might have taken advantage of that. But as we all can see in here, this is about one of the scariest things I've ever seen. I explained to him on the phone, I said, I don't know how to quite articulate this. Yeah, out of all the amplifiers I've worked on, this would be in the top 5 of the scariest things I've ever seen come in here. There's just a lot. There's like wire, there's like electrical tape holding this wire together. It then goes to so this wire nut goes up to the, this is ground. Holy shit, this wire here with the electrical tape on it, electrical tape through the ferrite core is ground. This is our hot lead through this wire nut from the front of the amplifier. And then that goes down to this positive post, and the positive post goes off. There's a single pass through that piece of ferrite and a single pass through this piece of ferrite. And it goes down to a trace on the board, and then that goes through another piece of ferrite. Oh, Lord Jesus, look at this. I just twist this, and this is about ready to fall off. Oh, this is amazing. Anyhow, enough dwell time on this. We're going to move on. I don't want to make anybody feel bad. I don't want to be that guy. I'm not interested in that. Okay, let's go over here to the Sweet 16. Okay, right off the hop, we see that this combiner here has been burned up, which tells us this one is still fully intact. Or is it? No, this one's burned up too. Oh boy. Okay, so the note said that this had too high of a dead key into it. The final section isn't burned up, but this is black. And we come look at here, this one's also burned up. Ooh. This one departed the smoke in a grandiose fashion. We can see the burn schmew. Well, the front of this face is like so. So the burnt schmew is all from here. I don't see any pop pills. But of course then, when this thing was last rebuilt, let's look at the notes. Oh, let's see here. Please note this was rebuilt in 1989, then again in 2002. Whoever did the repair, they put very large 10 ohm resistors in here, so. These are Toshibas. These are legit, old school, ball smash, no F's a given Toshibas that are in here. So, let's see what we got to work with. See what we got to work with. It does have more than adequate amount of power plug on the back, doesn't it? 300 ampere. Yeah, buddy. All right. So what we're going to do, because I know this gentleman's listening to me, he's not going to be really able to see what we're doing. He's going to be listening to me. What we're doing here, brother, is I'm gonna hook up the power wires for the Hot gauge cable I got for the 300 amp plug I've got. And hook hot to hot and ground to ground. Make sure the amplifier is off. So hot, hot, we verified our poles. Let's plug in the amplifier. Let's go ahead and we'll hook up to the antenna connector. We're just going to bump this with a small dead key. This thing's been in this room and it's very cool in here today, thank God. We're going to fire up the FLIR. And at the price that these transistors are, we have to verify how many are dead. So we'll see what turns on and what doesn't turn on. So right now everything's cool. So our baseline for everything is about 70, 80 degrees, 77 degrees. Let's see if we can run through the amplifier. Yep. Okay, we're getting a little power through it. Now we're not going to modulate this. We're just going to bump it up and see if the transistors, if the, wow. Okay. Look at that. The relay is floating around loose. Look at that. It's not even hooked up to the final output tuning capacitor. Look at that. That would cause all of these problems. Maybe I get to call this guy with some good news. That'd be awesome, right? So let's take a minute. Let's unplug this real fast. And gentlemen, like I said, I'm working for somebody that doesn't see so hot in this video, so I'm going to be doing a lot more talking than I normally would, so he can get a little bit more out of this. Let's run a little piece of wire through here. We'll do ourselves a favor. We're going to mechanically tie that in place. So your primary combiner, so how it works is you have sorry, I was working out of frame. I zoomed way in. Apologize, everybody. 4 2-pill sections. RF comes in, it gets broken up evenly. It goes from this splitter, then it goes to this splitter. So half of the signal that comes from this splitter goes over here, the other half goes from here. Well, we do the same thing on the output side. The RF that comes from this board, this board, this board, and this board, these two boards get combined here, goes to this combiner. This RF gets combined from here, goes to this combiner. And then it's got to pass by its final amount of capacitance or ground reference to make sure it's at 50 ohms to go outside of the cabinet. Well, that capacitor was completely disconnected, like it just broke off. So what we did is we mechanically tied this together now, and now we've gone and we've soldered it into place. And what has caused that is this relay floating around. You see how that's moving? So fix this technically. If that capacitor goes away, God man, hopefully this works. If that capacitor goes away, it could cause all of this guy's problems. But usually, we're doing a long shot right now. Maybe this will work. But usually this does wipe out a pill as you're going down because nobody realizes they have a problem. They just know the amp's not putting out and say turn the drive up or whatever. Okay, so at 1, 2, we'll talk through the amplifier. Let's grab our trusty dusty FLIR, turn the amp on. It does key, oh, it made power. Does key up. Those transistors are working. Those are working. Oh, those are working. And the back ones are working. Let's see, is anything getting hot up here? Nope. 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 These aren't getting hot, neither is this here. Oh, yeah, 600 watts plus. Okay, so we just took 18 watts. The amplifier's on 12 volts. We just put 18 watts into the amplifier and it made 600 watts worth of output power. Let me show you what I'm looking at. This is, see with my finger touching it, is the output combiner, this thing here. If there was any imbalance between these two sections, it would show up here as heat in these resistors. No heat. 1, 2, 1, 2, 1, 2. And I mean heat, it would show up like this. Heat. Like heat, heat. You see that? Versus that. Bud, you won the lottery. There's $2,000 worth of old school Toshibas in here. And none of them are burnt. Wow. You are one lucky dude. Man, okay. So, from here what I gotta do is I gotta pull these combiners apart and I gotta put new resistors on them. It's a must. I'm going to call him back and I'm going to give him the good news. I'd love to do a power wire upgrade on this for him and make it run really good for him. This thing is, honest, all in all, in pretty good shape. Wow. Lucky dude. From nightmare to easy fix. Wow, look at that. Remember that scene in Days of Thunder? Where homeboy's sitting there looking at that car that's sitting there in a frame and he's like, man, I'm gonna lower you down. I'm gonna shave a full inch off your bottom skirt and I'm gonna put a 3-inch wide fuel line in you and make it so you never have to, you know. He's like touching the car. He's like, I'm gonna make you so sweet.
I'm gonna give you an engine, low to the ground, extra big oil pan will cut the wind from underneath you. It'll give you 30 to 40 more horsepower. I'm gonna give you a fuel line that will hold an extra gallon of gas. I'm gonna shave half an inch off you and shape you like a bullet. And when we get you primed, painted, and weighed, be ready to go out on that racetrack. You hear me? You're gonna be perfect.
Just got off the phone. I'm having one of those moments right now. I'm looking at this Texas Star as I do with all of them, and I go, okay, let's make this actually do some cool shit. Rough. This guy, I called him, I said, man, you need to go buy a lottery ticket. He goes, that means that's good news. And I said, yes, this is great news. I said, we got a small couple little repairs that we need to do to your output combiners. He says he's very familiar with the inside of this thing. He's very familiar with how it's laid out. I said, you need to go buy a lottery ticket. And then I broke it down for him what had come apart, what was broken. And I said, obviously I got to fix this and this. And I said, you know, you're like 20 or 30 bucks in. And I said, do you want me to do the power wire? And he goes, yeah, well, how much is that going to be? I'm like, a little bit. So the price of wire's gone way up, yo. And just everything's gone up. So, needless to say, he says, yes, do power wires. I said, okay. So we're going to do him some power wire upgrades here. We're going to bypass his fuses. And we're going to make this thing jump. He also wants me to make the fans full time. And I said, okay, that's great. The reason that's great is because we're going to use your fuse holder. We're going to move this fuse holder from here to over to here. We're going to remove this wire that powers the on-off switch. The reason we do that is for the fan kit. If for some reason amplifier's on and the fan kit gets unplugged, if we make it full time, it'll blow this wire up, and then it blows this trace up, and then it blows the trace up from where it goes from over here on the board to over here on the board. So we put a fuse over here. That's the reason Texas Star started putting fuses in this thing instead of this solid wire. So let me get all the bits out of here we don't need. We are going to reuse the 300 amp Anderson clip. We are going to use 4 gauge to feed this thing. Then we'll come back in, we'll rerun some power wires in here. I'm going to pull these apart and repair these and make them so they're minty mint. He says this is the second set of pills that have been in this. In 2002, he had it repilled. And brother, you honestly won the lottery, because usually when that cap comes off, bad shit happens in a very fast fashion. The other thing we're going to do is we're going to disconnect this relay. We're going to pull it out, and then we're going to go ahead and use 3M VHB double-side, what everybody calls servo tape in the RC world, double-side stick tape, very high temp. And the idea is to immobilize this relay and make it so it can't flop around, and we don't ever have this problem. None of these other wires, none of this other stuff ever breaks down ever again for this guy. We'll make it bulletproof, and he can run this thing until, well, his kids have to figure out what to do with it. So let me do my job. I'll see you. Bye. So it turned out okay. I don't mind how this looks on the inside. But, you know, I went up in the house and I was talking with my wife. We were talking about this other situation and how bad this is. And she says to me, she goes, well, you know what you're going to do? And I said, yeah, I do. I said, baby, I hope you don't mind, but I'm going to go out there and I'm going to take care of some stuff. And she goes, no, babe. We're looking at pictures of this. And I said, what I couldn't understand is it's just like somebody plopped the thing in here and then just kind of laid all the parts around it. She's like, I don't understand what's happening. I'm like, yeah, me neither. She goes, well, what are you going to do about it? I said, I'm going to do my thing. So let's just go in here and trim the trees. What do you think? So then this happened. Yep. Mr. D, please don't be upset with me, but I could not, in good conscience, let this piece of equipment come back to you in the state that it was in. I was afraid that it was going to either catch on fire, cause your shack to burn down, or you were going to get electrocuted. I couldn't. And I was talking with my wife about it last night. I'm like, listen, this guy I think got bent, like somebody bent him over completely. And she goes, baby, go do a good deed. So please don't get mad at me. I took your amp completely apart. We stripped it down to the bare bones, and I started completely over. So what's in here now is a SB, or a DPS, pardon me, 1200 SB, which we've modified to run at 14.5 volts, which you guys seen in the last segment. The fan is in here so that when this thing is closed up, that there's a little bit of air circulation through the cabinet. We want to have air flow through and by this power supply. This is a really cool bracket. Let me find the paperwork on that. if I can remember where I put all of them. Just bear with me 1 second, y'all. There's this super cool kid, or not kid. His name's Jeremy, and it's Derek. He's on the BBI Amps group on Facebook, and he 3D printed a whole bunch of these for me to test and play with. He's not quite ready to start making these for mass production, which I wish he was, but you know, it's just some guy in a printer, one printer, I think. I think he's up to a couple now. This thing worked out perfectly. This little, I mean, thing is in there. It's not moving. It's not held in place with parachute cord. This is paracord for like a parachute, right? The way this is set up, that if you want to in the future, all you got to do is cut the end of the cord off and put a 220 plug on it. It'll run on 110 220 auto switch internal, so you never have to go in here for anything ever again. The only thing that we recycled were your switches. I kept them in the same orientation that they were before. So of course that switch is on, and then amp down of course is on, and then the sideband delay. We kept your variable in play, and the only thing other than that we reused was the LEDs. We completely rewired how the switches were hooked up in the front, so now they're actually electrically correct. So cleaned all this up and reorganized all of that. So we kept the case, we kept the variable, we kept the back of the cabinet. Other than that, this is all brand new. Because of the way the heatsink mounts to the back of the cabinet, actually, for the first time in probably 8-9 years, I got to Dremel hand cut a board. I was super stoked about that. This is a ICA 1x2 heatsink and board that's cut down to fit inside this cabinet. I did have to cut 2 fins off the heatsink on the back, but there's substantially more metal meat back here than this sad thing, which I'm sure worked fine, but I couldn't in good conscience. So you got an all brand new heatsink on the back of this thing, significantly larger. Let's see, inside, of course, we used my transformers. I used my transistors, which are 2290s or 2879 HGs, by the way. These HG 2290s, they've got problems in my opinion, that's why I don't use them over here. So basically it had a 30 amp wannabe switcher in it, which was making so much noise when you turned it on you couldn't hear through the amplifier. You could not pass RF through the amplifier. The pass-through SWR was through the roof. We fixed all of that. Brand new Japanese relay in here. So you've got a 100 amp power, or 80 amp on 110. Pardon me, 80 amp on 110. 80 amp switcher in here now. I would still appreciate it if you used this probably like a 30 or a 45 amp, and that's simply because the amount of current that the plugs can carry. If you're going to want to run a radio or some other piece of equipment off the back of this, you more than can. It's fully utilized. We did a common case ground on this, which is the proper electrical way. There is no way for me to put my hands in here with it plugged in for anybody to get electrocuted. We did this novel thing called heat shrink. 600 volt epoxy based heat shrink on the fuse holder. And then on the back of the switch, we did 600 volt epoxy based heat shrink on the back of the switch. Versus 1, 2, 3, 4. I've had a lot of fun with this. I've been putting pictures up I put them up in the Patreon group first, and I was just gobsmacked. I mean, the longer I looked at this, the worse I felt about it. And this is one of these things where you just got to step in and take care of it. You know the customer is not wanting to really pay for this. He didn't want to sink any money into this. So I can't go to him with that emotional burden. like financial burden or nothing. I can't go to him and say, well, you know, I completely rebuilt that thing and you owe me $1 million. No, 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 no. It's not the way this works. I took it upon myself to do this, so therefore I cannot go after him and say, hey, you owe me whatever. If he wants to kick me a couple extra dollars after watching this, it's entirely up to him, but I'm not expecting that at all. We ran all brand new RG316 coax up here to your variable, brand new 5 watt 100 ohm resistor off the back of the variable. Variable does work. It is a wire based variable. So a smart person would run this all the way open. Okay. This is technically the wrong variable for what we're using it for, but it's got the right resistance level. It will work, it's just in the middle your SWRs are going to get a little high. Input on the input side. Pass through SWR and this is perfectly flat. 316 out to the coax connectors. I did reuse your coax connectors, but then again this is only, let's face it, this came in here maybe if it was lucky 100 watt linear, and it's leaving here a 500 watt linear, so take it easy on me, you know what I'm saying? We are going to reuse the external cabinet. This two-piece made out of straight from Home Depot galvanized piece of metal for the back. The inside was covered with aluminized tape, and I think that was his attempt to try and keep the noise in. It's the same thing that was going on with the power supply over here. The power supply, as you can see, all the vents and all the openings on the power supply were completely blocked. So I don't know what the point of even letting the fan be open was, but it is what it is. That's what it is, right? I went ahead and I opened this up. The fan, like I said, is just here to let air percolate up through the cabinet, let the internal source on this thing, because everything was sealed. The bottom was sealed up, the top was sealed up, everything was sealed up. The sides are sealed up. This was sealed up. I don't even know what the point of putting that on there was, but it was sealed up. So I think this goes like so, but underneath. I don't know. I'll figure this out in a little bit. So we open it up so you can get some airflow through it. I made it electrically safe to the point where I don't have to worry. I get to go to sleep tonight knowing that this piece of equipment is not going to kill you for any reason. Let's go ahead and run through the basics on this, and then I'm going to take everything off of here because the workbench is covered with a mile of shit from drilling and tapping and cutting and twisting and Last night, I decided to take this on last night at about 10 o'clock. Last night, got done talking with the wife. She says, go do your follow your moral compass, go do a good Samaritan deal. I said, okay, yes, ma'am. At about 1:30 last night, when I finally got to where I was mounting this up, you ever get yourself so tired that you just start making mistakes as you're building something or working on something? About 1:30 last night, I went to hook this up and try and test it for the first time. And it dawns on me that I had wired to relay backwards, and I'd also wired transmit receive on a relay backwards, which is like the most rudimentary thing on the face of the earth. And I'd reached that level of exhaustion. I don't know if you guys have figured it out yet. I'm going on a huge trip here fairly shortly, and I'm trying to do a huge push to get a lot of this equipment done so I don't have quite the workload when I come home. This is a working trip. This is not a vacation by any means stretch of the word. This is completely radio based, 100% all about work. I just needed to get into the high 20s, which I'm at 20, well, this is 25, 26, I got 27 and 28, 29 and 30 already all in the works. So it is what it is. I digress. This has got every upgrade in it except for bias for sideband. It wasn't in here before. I'm not going to twiddly fart around with putting those parts in here to make it work, but this thing is right. Let's go ahead and turn on the amplifier. Little fan circulating air. All right. Let's look at our output voltage. We're running at 14.5, dead nuts on the money. It's a 1,000 watt slug, 1,000 in average, 5 watt slug in reverse. We have seen this before. Remember, switches up on this thing mean off. So, amp in standby. Hello, 1, 2, 1, 2. Putting about 25, 30 watts into it. Let's get you square on so you can actually really read the meter. This is to show us pass-through tune. Otherwise, the RF's ability to go in and come out of the amplifier. Hello, 1, 2. Hello, 1, 2. There is no electrical resistance to the RF. This is the volume at maximum on my radio. There are no harmonics in this power supply. Let's turn the amplifier off. Amplifier back on. The reason that test is important is thinking back to the beginning of this saga, which was yesterday. The amount of noise when we'd turn the power supply on was like 20 dBs, and the poor guy couldn't hear anything. Well, we fixed all of that. Now he can talk through the amplifier, he can hear through the amplifier, he can run other pieces of equipment off of it safely, and he's got room for growth. All right. Let's do the tail end of this thing. Okay. So, with 30 watts hitting this thing, hello, 1, 2. Turn the amplifier on. Hello, 1, 2. Make about 220 watts. This is intentional. The amplifier that he sent up here was about a 220 to 250 watt amplifier, right? So with the right radio, he can still operate the amplifier the way it was when it came in here. Hello, 1, 2, 1, 2, 1, 2. Okay. Let's go look at our input SWR, our input reflect. Let's go ahead, pan, and lock it down. Okay. Hello, 1, 2. Hello, 1, 2. 0.2 of 1 watt worth of input reflect. I don't know what it was before. I was afraid to hook it up and key it up. Many of the comments that I got was, well, did it even work? My answer to them was, I don't know. I don't know, and nor did I really care. I mean, that's some tweaked up Jenny Crank methism going on here. Like this. I dig the Texas Star fuse holder, by the way. That's awesome. I mean, that's awesome. I probably might salvage out of that pile of shit the snap over ferrite rings once I figure out what they are. Other than that, all of that is going in the trash. All of it. So, we've got ourselves a 250 watt linear, right? Or do we? Let's grab the D-Rail 955 Striker, the bench D-Rail 955 Striker. Turn the amplifier into standby. Now let's go back over and look at our watt meter one more time. Hello, where'd it go? As you can clearly see, that is 125 watts worth of drive. Now look at what happens when we run the amp with a little bit more drive. Hello, audio. Hello, audio. 1, 2. We're making over 500 watts, about 520 watts, 515 watts of power. Let's go over here. Let's look at the Striker in front of the bird meter. Now, I'm not setting this up for a 100 watt radio. I'm setting this up for a 20 watt radio. There is a little bit of input SWR. Hello, 1, 2, 1, 2, 1, 2. This is one of the deals where the bird watt meter and the Striker can strongly disagree about things. And I think it's because my dead key is so low. Yes. We're at 3 bars on the Striker and 0.3 of a watt worth of reflect going into the amplifier. But on the output side of things, there we go. Let's unlock the tripod. Hello, audio. Hello, 1 2 1 2 1 2. I morally, mentally, and emotionally could not let this go back to the customer with the way it was configured. Let's take a look at the voltmeter. We're at 14.48. Hello. So we lose 0.2 of a volt. 0.2. As frustrating as this was to do, I personally have really enjoyed getting to bang my head against the wall to do this. It's got the actual C13 or 15 plug or whatever it is in here. It's fused properly. All the 110 volt connections are heat shrinked and covered. There is no electrical tape anywhere in this thing to be found. Everything is through hole soldered, wrapped and twisted. This will not come apart in shipping, and I don't care. He'll be able to plug this in on his side of the street and actually be able to use it, and no one is going to get electrocuted. At any measure, step of the word, thought of the idea, this is a win and a vast improvement over what it was. All right, let's go back and look at the other amplifier now. Let me reset this. Let me clean up my workspace. Let me put all this away. I'm going to put the lid back on this and get it ready for transpo. I think I'm going to do this last bit of this, edit this video, and my ass is taking the night off because I am beat. I'm mentally beat up. And I need me a little bit of a break. Just noticing this as I screwed this on. As I go over this, please forgive me. It has been a blizzard of amplifiers the last couple days, and I can't remember exactly where I left off on this story. So I think we were talking about it before I did all the power wire upgrade. Okay, I think. So if I cover something again, please forgive me. Like I said, old fat man needs a nap. And an old man nap. We went ahead and we kept your pre-existing connection. I did have to replace one of the clips inside of this thing. Yours had a big hole down the side of it and it made it a little bit tough to solder it. So I just went ahead and I put a new clip in here. This is still your stock connector, but instead of having it come this far off the amplifier, about 3 or 4 inches, I went ahead and I put about a foot worth of 4 gauge, which is really super soft, which will make it easier for you to mount it up, move it around, and work with it. You did get a full power wire upgrade. We rebuilt the output combiner. That output combiner, tested them. There's no leakage. I had to rewrap this one because it had been burned up so bad that where the wires crossed over each other on the ferrite, the mag wire, the coating had burned off and it was causing it to have the wrong unit Henry rating. So we went in and we fixed that. We upgraded your fan, so it's going to be constantly on. No, I don't need to worry about a fan kit for this. This guy's got some kind of system he puts this in where it gets air on it, but it does operate off of the fan jack in the back. So we went ahead and this is a 10 amp fuse that we put here. Although the trace that passes from here to here, 10 amps is asking a lot of that little trace, but if for some reason the fan gets plugged in when the power is on, either here or plugged in, you've got the fuse as protection. Where we left off, the last that I remember was that the wire had popped off here. We hardwired connected that. The other thing is that the relay was floating around. Relay is not floating around anymore. It is securely mounted. I completely took the relay out. I cleaned all the contacts on the relay, put it back together, reattached it to the board so it can never move again, so we don't ever have to worry about the wires breaking off the relay or any of the stuff attached to the relay breaking free from anything. That's it. That's it. Okay. So, amp is off. We're going to use a derail bench 955 striker. Hit 0 and 2. We're going to put 120 watts worth of drive into it. All of our measurements will be taken with 120 watts worth of drive. Pass through tune. Hit 0, 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 hit 0. Perfectly low. Okay. We are in the 1,000 watt scale. We are running at 14.8 volts. All right. Amplifier on. Whoa. That's not the results I wanted to see. Let's stop. Let me reevaluate. If you go back and look at the previous video segment, you'll see this little orange wire isn't hooked up. This relay, all it does is switch 12 volts, which I've covered in many videos. What it does is it turns on the biasing circuit. So from here, these wires are all, the boards are jumpered together. Well, this little orange wire jumps over and it runs this relay. I had no transmit receive, like the relay was not moving. So all I did was like, ooh, here we go. Flip the switch and the relay didn't engage. So let's try this again. Hello, audio, 1, 2. So 600 bird and off the scale. Now we'll go to the 2,000 watt scale. Hello, audio. Wow, this thing works really freaking good. I'm glad to be done. Right here, between the 40 and the 60, that hash mark right there is 1,000 watts. We're on the 2x scale. So the next big mark, which is a 60, is 12, 14, 16, 18, and then all the way at the end is 2,000. So, hello, 1, 2. Hello. Showing 1,800 peak. Hello. And about 600 bird, which is really good for a Texas Star. It's not that great for 8 transistors. It's 500 watts less than what we could get out of the same parts in a different configuration. But for a Texas Star, this is really good. Okay, let's go up here. Check this out. Hello, 1, 2. About a half a watt worth input reflect. Not too bad. The front of the striker isn't tripping out too bad. This is a factory tune, by the way. Did not mess with the input or output tune, so it should work exactly the same, just with more power out than what you had when you had it in your setup at your place. Hello, audio. Let's look at it from my point of view. Hello, audio. Oh man, I'm ready to be done. Gentlemen, I'm gonna walk. Nothing caught on fire, nothing blew up on camera. That's all I care about. Oh man, everything tests out great. Mr. D, you're done. I gotta take off and run out of here. I gotta go pick up parts that just got overnighted to me so I can finish one of my other RO projects that I'm working on. This is done. I'm gonna put this in the done category. I'm going to get both pieces of equipment boxed up and you're going to hear from me in a little bit. Gentlemen, I want to say thank you. Big thanks to my Patreons. You know, this entire video was brought to you ad-free because of their support. You've gotten to enjoy over an hour's worth of content on YouTube with no ads. No adult diaper ads, no Liberty Mutual ads, no State Farm ads, no ice cream ads. I know a lot of you guys use ad blocker, but for those of you that are trying to watch on the phone and you don't want to go about hacking your phone and putting a blocker on it, I'm sure you're grateful. If you've ever learned anything from this channel, want to help support in any way, please take a minute, come to patreon.com. Please come help support. I can't even express to you how much stuff is getting ready to go down in the next couple weeks for me in my life, and it's all because of the support of these guys here. I'm eternally grateful to every single one of them. And I mean this honestly, I say it at the end of every video, I don't get to be here without you guys watching, giving me a thumbs up, helping show support. I mean that truthfully. It's not, oh, that's just my line. I mean it, I say it, I've said it now for several thousand plus YouTube videos because it is the truth. Big shout to Siglent, MechMan, Penalabs, XS Power, Bird, Coaxial Dynamics. And a big thanks to every single one of you guys, even though you're not one of the Patreon guys, still you watching, giving me a thumbs up, following along, and seeing what I got going on with this Dog and Pony show. I thank every single one of you guys. I'll see you, gentlemen. I'm going to run. Time to put the lid on it and move on with my day. I'll see you. Click, click.